Welcome to my presentation. In this presentation, let us look at some vector operations in 3 dimensions. Um, Let us take an example here. In this example, if A is a vector, let me clean this thing up a little bit. If A is a vector and if the components of this vector are 2i plus 2j minus k, and if B is another vector, and if the components of this vector are 6i minus 3j plus 2k, we want to find the angle between these two vectors. We want to find the angle between these two vectors. Okay, so just to represent it in a diagram manner, if this is vector A and if this is vector B, we want to find the angle between these two vectors, and if we call the angle as theta, from the information what we know from one of the properties of vector operations, we know that the cosine of an angle is equal to vector A dot vector B divided by the magnitude of vector A times the magnitude of vector B. So that's the way the angle is defined as. Therefore, we know vector A, we know vector B, and we can perform the operations in here now. So therefore, step number 2, we're going to substitute the values. Cosine theta is equal to the dot product of vector A and vector B. So vector A, we have 2i plus 2j minus k dot, and then vector B is 6i minus 3j plus 2k, this whole thing divided by the magnitude of vector A, which is going to be the components, each of the components of vector A raised to the power of 2, 2 squared plus 2 squared plus negative 1 squared, like that, times the components of vector 2 raised to the power of 2. So 1 raised to the power of 2 plus negative 3 raised to the power of 2 plus 2 raised to the power of 2. And that is under the radical term, like that. Now it is matter of simplifying the terms. As step number 3, we will also write this in here, that I dot I is equal to 1, j dot j is equal to 1, and k dot k is equal to 1. These are some of the properties of vector operations. Also, I dot j is equal to 0, j dot k is equal to 0, and k dot I is equal to 0. Okay, so keeping that in mind, we will simplify what we have here. So we'll call that as step number 4, and we will simplify the process all the way through. So in here, cosine theta is going to be equal to, in the numerator part, we have 2i dot 6i, that is going to be 12, I dot I, therefore that's going to be 12. Then 2i times negative 3j, that is going to be negative 6ij, ij is equal to 0, so therefore we're not going to write that. 2i times 2k will be 4ik, which I dot k, which will be 0, we're not going to write that. Then we're going to go to the second element of the second component of the first vector, and then multiply all the elements, all the components in the second vector. 2i dot 6i will be 12ji, that is going to go to 0. then 2j times negative 3j, that will be negative 6. J dot j will be 1, so we'll just write it as negative 6 like that. And then j dot k is going to go to 0, and then we're going to take the third component of the first vector and then distribute it out to every one of the components in the second vector. Negative k dot 6i, that is going to go to 0. Negative k times negative 3j, that is going to go to 0. And then we have negative k times positive 2k, that is going to be negative 2k dot k is going to be equal to 1, and therefore we have negative 2 left. In the denominator, we're going to simplify these radical terms. So we have 2 squared is 4, 2 squared is 4, negative 1 squared is 1, so that is under the radical term, times 1 squared is 1, plus 3, negative 3 squared is positive 9, plus 2 squared is 4, so under the radical term. So we'll simplify this some more. In here, when we simplify, this is going to be 12 minus 6 is 6, 6 minus 2 is 4, divided by 4 plus 4 is 8, plus 1 is 9, square root of 9, times 1 plus 9 is 10, 10 plus 4 is 14, square root of 14, like that. So therefore, let us trace back to see whether if we have done this correctly. So in the second component, we have, this is 6, isn't it? So we missed that part here. This is going to be 6 raised to the power of 2 plus negative 3 raised to the power of 2 plus 2 raised to the power of 2. So 6 raised to the power of 2 is going to be equal to, I'm going to make that correction here, that is going to be equal to 36. 36 plus 9 plus 4. So I'm going to correct this one as well. So 36 plus 4 is 40. 40 plus 9 is 49. The square root of that. So when we simplify this, this is going to be 4 divided by square root of 9 is 3, and then square root of 49 is 7. So we got all the simplified form in here. So we can write this one as 4 divided by 3 times 7 is 21. So we want to simplify this some more. So therefore, cosine theta is equal to 4 over 21. We want the value of theta, the angle between those two vectors. We can write this one, we can express this as cosine inverse 4 over 21. Therefore, this value, when we use our scientific calculator, the value is going to come out as 79.0194 degrees, or you can also round it up to 79 degrees approximately. The value of theta, or the angle between these two vectors, is 79 degrees. This is where we want to leave it. So we can use the properties of vectors and then simplify some of the vector operations in 3 dimensions. In my next presentation, we shall look at some more examples related to vector operations in 3 dimensions using the vector properties.